And then y'all can get to practicing the 6-6 homework assignment. I have the review already printed for you. Remember the goal. Remember why we were working so hard last week. And we're going to continue working hard this week. It's going to crash. Remember the goal is the exam being this Thursday so that you have this long weekend of no studying necessarily. You are. I was trying to show you the calendar and the stupid thing froze or crashed. Alright, so look at the calendar. We are here. Nope. We are here. So this Friday, y'all do not come to school. We do. We have meetings. And then Monday and Tuesday, everybody's off. So these are those built-in inclement weather days that if we had a ton between the beginning of the year to now, and we had to make up days, they would go on the calendar and say, you know what, y'all were off Tuesday, now you got to come to school. That's what these are for. It also recognizes a bank holiday right there. That's President's Day, which is a bank holiday. So no school Friday for y'all, and then no school Monday and Tuesday. You get a nice long weekend. The PBIS field trip is the following Friday, so keep up with that in the back of your mind. So we are aiming, and we're on target, like it's going to happen, okay? So don't come in Thursday and say, Miss Holcombe, I'm not ready. That would be because you didn't get ready. You need to get ready for this exam Thursday. It's Thursday. When's the exam? Thursday. Except for you, because you won't be here. We already got it planned. So the exam is right here, and I already have the review. I'll give you a copy of it. I think, if I'm not mistaken, it's 20 questions. And I have the printout review, okay? All right, so now we need this. So 6-6 normally takes 2 days. Honestly, we could possibly finish the notes today, but then we normally spend like a day of just answering questions, or we can move on into the review, depending on where y'all are. There's only 10 slides, 9 slides of notes, and this first slide is the title. We are looking at transforming the graphs. If you remember me saying we're only going to focus on sine and cosine because those are the only interesting ones. We are not transforming tangent because nothing fun happens there. Okay? If you recall, when you had in college algebra, do you remember the transformations of a quadratic? A determines if it opens up or down. It also determines if it's a stretch or a shrink, vertical stretch or shrink. B was the new one where it determines if it's a horizontal stretch or shrink. H has a sign change, and it referred to shifting right or left, and it was always opposite, right, of what you saw. And then K shifted up or down, and it was always exactly what you saw. Remember that? Okay, good, because that is exactly the same concept here. There's a little bit of extra stuff in the details, but those exact same properties are carrying over. Okay? So I'm going to go to the next slide, and I'm going to basically let you copy everything down as I talk about it. Okay? So if you'll let me, instead of looking up here, writing it all down and not knowing what you're writing, only write what I point to, because then I'm going to explain it as we go through it. So here's the slide with all of the information. Let's see, I'll go to pointer. All right, there's a lot going on here. Don't get overwhelmed. Let me break it down for you. We have the sine function, we have the cosine function. They are identical besides the word sine and the word cosine. You will notice the same letters A, B, C, D that correspond with A, B, H, K, right? Same concept. I did do capital letters, and that's just because of the lowercase letters. It kind of makes, I don't know, it just looks weird because of the word sine. So I did capital letters. All right, what does A do? So everybody should be writing down what A does. A does the same thing it does with quadratics. It controls if there's a vertical stretch or shrink. Because we're now talking about trig functions, if I'm talking about a vertical stretch or shrink, I'm changing that amplitude that we learned on Friday. Which is why I wrote right here, changing the amplitude. So if there's an A value other than 1, the amplitude has been changed. If A is negative, now this is the fancy way to say A is negative. A is less than 0. If it's less than 0, it's going to reflect over the x-axis. You already know that from quadratics. If A is negative, it reflects down. Okay? So A is familiar stuff. The new part is when you turn the volume up or down, you've changed the amplitude. All right, that's A. Can we talk about B now? All right. I only want to talk about it as you're writing it. All right, B. So I wrote a really big arrow because I didn't want this to get crowded. B controls the horizontal stretch or shrink. Think of an accordion. Horizontal stretch or shrink. In terms of trig functions, from what we learned Friday, think of an accordion. The horizontal stretch or shrink means that curve that I'm trying to graph either has only a certain amount of time to do the curve, or now it has an even longer amount of time to do the curve, which is why the accordion concept is helpful. Think of an accordion. If I stretch an accordion out, actually, let me back up. Y'all do know what an accordion is, right? And I am using the right one, right? It's the one where you slide your hands on the left and the right, and it, yeah. What is the middle part? Like, what is it, paper? Or like a canvas? Okay, so you know, it's like if you take your paper straw and you fold, and then you stretch it apart. It's like a, yeah, it collapses or it'll stretch out, right? Okay. I want you to think of an accordion as the sine curve or the cosine curve. Like starts here, stops here before it repeats. You with me? We don't want to focus on when it starts repeating. We want to focus on the curve, right? So if I am changing, if I have a value of B in there other than 1, then it's changing the accordion. So it's either stretching it out, so now that curve is stretching out and has more time to run, or it's shrinking it in, and now that curve is really busy because it's got to do the curve from here to here. When you have a value other than 1, there's a horizontal stretch or shrink, and that means in terms of trig functions, it's changing the period. The period described how long the graph has to run the curve once. The normal period is 2 pi, 1 full rotation, right? To get the changed period, you take 2 pi and you divide by whatever B is, and that's your new period. So if this said, for instance, 2x, then I know, okay, I have a horizontal stretch or shrink here. I would plug 2 in for B, and I'd have 2 pi over 2, which reduces to what? 2 pi over 2 reduces to pi. So what that would mean, in a nutshell, is where the normal graph, let's see, this is sine. Sine starts at 0. So the normal graph goes like this to 2 pi, right? That's one period. The modified graph, if it said it's going to stop at pi, that means it's got to hit that curve and finish before it starts repeating at pi. Does that make sense? So the accordion has been collapsed. It's a horizontal shrink. It has less room to run the curve, which means it's more active, it's faster, right? If it was stretched out, it would have more room to run the curve. You see that concept? So hopefully that helps you. That picture was saying, like, for example, if it was b equal 2, then the period would be pi, because 2 pi over 2 is just pi. All right, now, 2 left. Phase shift. Right here, phase shift controls right and left movement. We no longer just say horizontal shift, right or left. We use the phrase phase shift, which is why it's highlighted to let you know this is a new vocab word. New vocab phrase, phase shift. How do you get the phase shift? It's really simple. You take the number in place of C and you divide it by B, if there is a B. If there is no B, then the answer is just C. B would be 1, so it would just be C. So this is a formula. Phase shift controls right or left movement. Remember, it is backwards from what you think. I see like -4. You would think left 4. It's actually right 4. I see +2. You think left 2. It's actually right 2. Sorry, +2. You would think is right 2. It'd be left 2. They're backwards. Anything in the parentheses is counterintuitive. Remember we said hold up. Think of capital H, like hold up. Wait a minute. Something in parentheses next to X is backwards from what it looks like. And then the last but not least, which is very straightforward, thank goodness, is whatever's at the end is literally picking the graph up or down, okay? Picking the whole graph up or down. I didn't label things for cosine because they're the exact same. I just labeled it for sine. They are the exact same. The difference is you need to remember the original functions look like this. And I highlighted the part you need to have memorized. You need to know sine starts at 0, goes up, curves, and stops at 2 pi. You need to know cosine, roller coaster, best part's a pi, curves down and then comes up and stops, right? So notice the difference between the two. You've got to have those memorized. If you forget them, you can generate it by asking yourself, what's the y value at 0? Plot it. What's the y value at pi over 2? Plot it. Y value at pi? Plot it. Like, so you can get it by knowing how to plot, or you could memorize it and make life easier. If you look at these over here. Okay. So this is me saying there's a couple of ways to see B and C. Those are the toughest parts, B and C. So here's 3 examples here. Notice this says 2, and then you have these parentheses understood, theta minus pi. That is the same thing as 2 theta minus 2 pi. That's the same thing. In this case, you've got your B is 2 and your phase shift is 2 pi, which means it is shifting right an entire 2 pi cycle, okay? And then down here where it has theta minus pi, this is saying take the normal sine theta graph, shift right by pi. that doesn't make sense yet, give it time. We're going to practice. We're just going to dive right into the graphs. Okay. So in my opinion, the easiest one to work with first is D, where you're just picking the graph up and moving it up or down. So go to this slide here. If you want, you could get highlighters and highlight, what the slide represents, so that when you come back to it later, it might help you. So the easiest thing to practice first is when you're changing D. D is the part at the very end. It represents picking the graph up and moving it. Okay, I need you to first of all know that there's two ways to see these functions. One way is sine of x. Another way is sine of theta. You need to be familiar with both. They mean the same thing. It helps if you can identify the mother function, then decide what's happening to it. So the mother function here, I'm changing highlighters because I don't want you to think that what I'm highlighting is D. D is the +3, right? But the mother function is just sine of x. If you'll highlight or underline or block the mother function, maybe then it'll help you see that the only thing you got to do here is graph sine and shift it up 3. Now we're gonna do this example right here. To graph sine, we are going to recall the mother function anchor points. Remember I said if you have the graph memorized, that's great. If you don't have the graph memorized, you need to know how to get the anchor points. So we're going to basically recreate that chart we did on Friday. We're graphing sine of x. Sine means on the unit circle, focus on which one? Sine. Sine means focus on the y value, right? The graph is sine of x, or sine theta, whatever you want to say. We're focusing on the y value. We're going to only hit our quadrantal angle values. So that's where the T-chart comes from. Everybody should know those quadrantal angles. We're going to plug it in for x, and we're going to get our value as we plug it in. You don't have to label the x, actually. You want to do it this way. I just did this. I just started listing. I got 0 pi. What's up here? And that would be pi over 2. I'm going to write it out in horizontal because it's going to get crowded. All right, 90 is pi over 2. What's here? Pi. What's down? 3 pi over 2. And then what finishes it? 2 pi. Those are just the quadrantal angles. All right, we're going to ask. Yeah. So in our head, or using your blue formula sheet, it's up to you, we're going to say what the y value is at these spots. All right, 0 pi, y value. Are you holding up 0?
Yeah.
The light's shining in my face. The y value at 0 pi is 0. Up here, y value, 1. 180, or pi, y value, 0. Down here, 270, or 3 pi over 2. What's the y value? -1, and then to close it out, 2 pi, 0. So we're going to graph this. Let's graph it in dotted light pencil, because it's the mother function, right? So we've got 0 pi. At pi over 2, we got 1. Pi 0, 3 pi over 2 is -1, 2 pi 0. We're going to go dotted. we are taking this graph and we are going what? We are literally picking it up and moving it up through. Is this going to change the volume of the song? No. Did we turn the amplitude up or down? No, we didn't. We are literally just relocating it, okay? That's important. This is already written on there for you. This is just shifting the whole graph up. It's not changing the amplitude. It's also not changing the length that it has to do the curve. It's just changing the location of it. So now I'm going to take all of my anchor points and I'm going to count up 3. That's it. So 1, 2, 3. 1, 2, 3. 3, 3, 3. And I'm going to now do a nice, and then I really do need to finish it to the other side because that's the period, but that's not the whole graph. So copy the pattern. Here. What is the normal amplitude? What did we say on Friday? The normal amplitude is, find that midline. The midline, I'll use a highlighter. The midline is right here. Amplitude is the height of the top of the curve to the midline. So it's just from here to here. It's 1. Normal amplitude's 1, y'all. Normal amplitude's 1. Okay? So we already said the amplitude did not change. So I'm just kind of prepping you for your practice questions. So the amplitude here would still be 1 because we didn't change it. The period, meaning the length of time that the curve has to do its normal curve, did we change it? Then it's normal full rotation, which is 2 pi. Now the good news is in your My Math Lab, though, you're not graphing these by hand. You're graphing them using a widget. We are practicing it right now by hand because it makes it a lot easier to understand once you do, like, go to the widget. In the widget, you would enter the values of what's changing. All right, you do the next one. You try cosine. It's shifting where? Down 1. This is the mother function right here. And then this means it's going to go down 1. This here meant it went up 3. Generate your mother function anchor points. Cosine means you're looking at x. You're writing the x values at the quadrantal angles. you get that? Did we change the amplitude?
No.
Nope. So amplitude's 1. Did we change the period? Meaning, was there an accordion effect at all? No. So it stays 2 pi. It runs its cycle to 2 pi. So when you have a value in place of D, when you have a value in place of D, it's like if you had a stamp that was the shape of the graph, you're just stamping in a different location, right? You're not changing the dynamics of the graph. They sent an email and said that at this time there's no plans to make up any days, but if we have any more inclement weather days, they will reassess and possibly make up days. Those built-in breaks would get shortened. You'd have to come to school. I say that satirically because we don't have anything this policy. All right, let's go to the next slide. So now what we're going to do is focus on changing A. This is the one in the front, okay? We're working our way towards the stuff on the inside because that's the hardest ones to work with. So now we're kind of going to the front of the graph. We're going to work on when you're changing A. I have given you a description next to it. This is going to change the amplitude of the graph. Could also reflect it over the x-axis. So there's 2 possibilities here, right? When we're changing the amplitude, I need you to think of the amps of like someone got a system put in their car. That means they got higher amps than what the car factory came with so that they can listen to the music louder, right? The bass gets louder. So think of it as turning the volume up. These sound waves, think of these graphs as sound waves. They're going to go nuts and stretch out if you turn the volume up. If you turn the volume down, right, then there's not as much activity going on because now they're compressed. So if you'll think of amps turning volume up and down, it really helps to know what the graph is doing. All right, there's 2 examples here from the textbook, and then I gave you 2 more examples just to kind of make sure. If at any point you're like, Ms. Holcombe, I got this, then we can move on. What we're going to do is plot the mother function, then we're going to plot the new one. So this is what mother function graph here? This is cosine x. And then if you notice, it has a 2 in the front. The 2 in the front is telling me that the amplitude has been changed, right? The graph is going to have an amplitude of 2. Let's plot our anchor points for cosine. You don't have to generate that t-chart again. Look back at the previous slide on your notes. You've got your anchor points for cosine. Let's see, cosine starts at 0, and then you've got the pattern. So we've got 0 here. So here is all right, we're going to take our cosine graph and we're going to turn up the volume because we have that A, changing A, which works out great because we have an amplitude of 2. This means where the amplitude is normally 1, now it's going to be 2. right? So if you think about it, I'm going to change colors here. Where the amplitude is normally 1 to that midline, now it's 2. So you can see that that point here is actually going to go here. Midline doesn't change on amplitude, y'all. Midline stays the same. So like this would still be 0, but where this was 1, now it's 2. It does stretch down, okay? Remember, it's always positive. So this is down here. Where this one was 1 right here, now it's 2. So there it is. And now I'm going to connect those big ones. And you can see where the amplitude got turned up. And then I'm going to copy my patterns over here. You might want to take a highlighter and highlight where I did in green to show that we were reading the amplitude as 1 and then we extended it to 2, both going up and going down. That's how we graphed it. And you might want to make a note to yourself, the midline does not move. The midline stays put. It's the actual height and bottoming out of the curves that move. Now, in my math lab, you would push the cosine button, and then it would pop up the, you'd have to plot the mother function. Cosine starts at 0, 1, remember? You'll click there, it'll produce the graph, and then a widget will pop up, and you'll find the one that says amp, and you change it to 2. And it'll graph it for you. Okay. Come over here, change sine's amplitude to 3. So plot the mother function for sine. Where you would say to yourself, okay, cosine starts up at 0, 1, sine starts at 0, 0. You also need to remember that sine, when it first takes off, it goes up, okay? Don't start going this way. That would be wrong. If you forget, remember, ask yourself, what's the y value at those quadrantal angles, and then you'll generate the mother function. All right, so 0, y value 0 at 90, it's 1, 0, and then you can see the pattern. All right, we're going to turn the volume up to 3. I'm going to take my highlighter, and I'm going to find those curves, both up and down, and I'm turn the volume up, right? So where this went to 1, now it's going to go to 3. And where this went to 1, it's going to go down to 3. The midline stays put.
You sure it's not Colby?
It is Colby. But he's out there with the class. Let's see. Stretching down. Oh, no, to 3. Come back to 0. 3. 0. right, did you get it? So the amplitude's 3. Did I change the period of the graph, the accordion effect?
No.
No, not at all. So it's still 2 pi. Now, if this function said 3 sine x plus 1, I would graph 3 sine x first. Then I'd pick the whole graph up and go up 1. All right, those were nice, pretty numbers. I didn't think that was enough. Let's practice when it's a fraction and when there's a reflection over the x-axis, okay? So that's what these two are. This is practicing both fraction and reflection. So it's the same concept though. What's the mother function? The mother function is sine x. This negative means we're going to reflect over x-axis. The 1/2 means we're turning the volume down, right? Where it used to go up to 1, now it's going to go to half. So let's plot our mother function. We actually already have it up here, right? We already got sine x mother function on the previous example. So just copy the mother function. All right, there's my mother function. I'm going to go ahead and change the volume before I reflect. So where it normally went to 1, it's now going to go to 0.5, which means we don't have an actual tick mark here, so we're going to mark it. Now, notice I'm not plotting the whole graph yet, right? Because we also have to reflect it. So I'll change colors so you can keep track of this. So I would, with my pencil, lightly say, okay, so like that's actually going to go to there. This one's actually going to go here. So my new graph is like that, right? That's my new graph with 1/2 in mind. Now I'm going to do what with it? Reflect over the x, which means the points on the x don't move. Points on the x don't move because you're reflecting over the x, right? So leave those alone. So 0, 0 doesn't move. But this up here is actually going to go down here. And I'm going to go ahead and make a note to myself like I'm going down, and then there's 0, 0 again, doesn't move. And then I'm going to go up 1/2, and then I'm coming here. And then I'm going to try my best to repeat this pattern, only going to 1/2. So 1/2, 0, 1/2, 0. Now you're not graphing these by hand, kids. Everyone said that. So we changed the volume. The amplitude is 1/2. Then we reflect it over the x-axis. Okay, you try this one. This is cosine, changing the volume, and reflecting. Hopefully you're not like reinventing the wheel. You've already graphed y equals 2 cosine x, right? You've already graphed that. So you're just doing what here? You're just reflecting over the x-axis. And you do have an amplitude. Amplitude's always positive, right, by the way, so don't write -2. You have an amplitude of 2. We've already graphed 2 cosine x. It was the first example. So I'm actually going to plot the graph from that example as like my mother function to work with. So there's my mother function I'm working with here, and I'm going to flip over the x-axis. Midline will not move, just the points not on the midline. So in my math lab, you would push the button for cosine x. You would plot cosine x mother function starting at 0, 1. It'll generate the graph. A widget will pop up. You would check the box for reflect over x. You would type 2 for amplitude, and it would then produce the graph. So this is where my math lab is actually helping you with less work. All right, that leaves us with B and C, and those are the ones inside the parentheses, which means they are counterintuitive. Go back to college algebra and think of when I held my arms up like a touchdown, and I'd say, think of a capital H, like hold up, wait a minute. Anything inside brackets, parentheses, enclosure, some type, is counterintuitive to what you see. So like if I see times 2, it's actually divide 2. If I see right 4, it's actually left 4. So everything's backwards. Let's work on changing B first. This will change the period of the graph. It's going to change the period. This is the accordion effect, if you want to write that somewhere on here. This is when someone stands there with an accordion and either stretches it out more or brings it closer together, which means the graph has either more time to do the curve or less time to do the curve. Okay? So look at example 4. It says sketch a graph of sine 4x. The mother function is sine. Whoops. The mother function is sine of x. There is a 4 there. If you go back to the slide where we wrote down everything that happens, we said to get the new period, you take the standard one, which is 2 pi, and you divide by the number you see. I see times 4, so it's going to be, period would be 2 pi over 4. And then you do need to reduce it, which is what, y'all? All right, or pi over 2, 1/2. So this means where the graph normally does the curve in terms of 2 pi, now it's pi over 2. So I want you to visualize an accordion opened up between 0 and 2 pi, and I want you to think of those quadrantal angles. You got pi over 2, pi, 3 pi over 2, 2 pi. So where it normally can go from 0 to 2 pi, now it's got to go from 0 to pi over 2, which means it's finishing the curve in a quarter of the time that it normally does. Hence the 4. You see, times 4, it's actually divide 4. Right? All right, so don't draw this. The graph normally, what is it? Sine starts at 0. So the graph is normally like here, right? Don't draw that. That's the normal curve. Yes? We have to shrink that down, and now it has to complete that cycle, but it has to finish, like this finishing point has to be at, what? What's it say? Pi over 2. So this finishing point has to land right there. Do you see the difference? It's like the, right? It's the accordion effect. It's shrinking it in. It's saying, woo, no, you don't have 2 pi. Now you only got till pi over 2. So that exact curve, go up, come down, and land, is now going to start at 0, go up, come down, and land at pi over 2. And it does need to be symmetrical. So like, what I mean by that is, come on. Alright, so this was our normal, right? Now my ending point has to be here. So you have to use like some symmetry here. So it's got to go up, come down, and land. And I'm actually going to do that again because I don't like how it did. It's going to go up, hit the middle, and land right there. Now, I would draw the rest of the curve, but I'm afraid that if I draw the rest of the curve, you're going to lose where the curve actually was. So I'm actually going to leave it alone. The curve would continue both directions, but that would be the like pattern in that shortened amount of time. Okay? Or I may draw it and highlight, I don't know. But you can see where it would do, it's going to go nuts, right? Period changes are probably the hardest because you have to plot that graph in either a shortened or lengthened amount of time. My math lab would have a widget and you would just type that the period is pi over 2 and it will put the curve in there, okay? All right, let's do this one. We got sine of 2x. Mother function is sine. There is a 2 in front of the x, which tells me that the period has changed. It's normally 2 pi. I'm going to divide by 2, so now it's pi. So where the graph normally... I didn't do that right. Where the graph normally runs from 0 to 2 pi, one curve, we have to now run it from 0 to pi. So take your ending point and plot it. Okay, it's got to go to here. Also has to go here, right? And then adjust your midline. So in the middle of the graph, I got to hit 0. So the middle of the graph over here would put me at pi over 2. And now I can see, okay, I'm going to go up and I'm going to come down. All right, what happens if we turn the volume down? All right, look at the next one. We got sine 1/2 x. So my period is normally 2 pi. I'm going to divide by 1/2. Be careful here. Please be careful. You can't do it in your head, then go to your calculator. Just don't type the pi in. 2 divided by 1/2 is 4. If you're trying to figure out why it's 4, it's keep, change, flip effect. If you're worried you're going to get that wrong, then just type it in the calculator, but don't type the pi, because then you won't get the nice, pretty 4 pi. So keep 2, change it to multiplication, flip 1/2 to 2 over 1, and then now you probably see that it's 4 pi. So when you turn the volume down, the sound waves get lower, right? So where the curve normally, this is sine, so sine starts at 0. The curve normally does that and ends at 2 pi. Now it is stretching out to end. Imagine that this went to like 4 pi, right? So this is that accordion effect where it's stretching it out. Remember we said it's bass backwards. I see 1/2, that implies shrink, but it's in and enclosed next to x, right? And so that's stretching it out. So this curve normally ends at 2 pi, can now end at 4 pi. So we're really stretching out here. So how do we get it by hand? All right, to get it by hand, we know that the end point would go off the graph, right? But the midpoint would be the new, like where we used to have it in. So this point right here is actually going to be here. And then all we're going to see is the curve up. The curve up needs to be in the middle. This is the new middle. So now you can see that all we can graph is the curve up. We can't even graph the rest of it over here. Technically it would be like that. All right, we've got cosine 2x. So the period is normally 2 pi. We have a 2 here, so now it's pi. Which means where we normally stretch to 2 pi, now it's going to be to pi. Cosine starts where? Up at 1. So this is up at 1. So we've got our mother function, normally is up at 1, right there. Now it has to end at pi. So our end of the graph has to be here. Accordion effect, shrinking it in. So we normally start up at 1, and we go down and then come back up. The middle needs to be down, so that's going to tell me that I'm coming here. That is the toughest one, okay? That's the toughest one because that's the accordion effect. That's the most challenging one. The last but not least is if we're changing C, and that's the horizontal shifts right and left, but they have a new vocab word or vocab phrase, and that would be phase shift. I'm going to actually just leave this up here because I just want to talk you through it. First of all, remember, this is once again, anything on the inside, hold up, wait a minute, it's counterintuitive. We do have the new vocab phrase phase shift. That's that horizontal shift right and left, called phase shift. In this mother function of sine, I can see this right here tells me negative pi over 2, which is actually right pi over 2. So the mother function for sine is normally I start drawing those dots and let me fix that. Mother function for sine is normally here, right? If we have a phase shift, there's no accordion effect. You're literally picking it up and you are shifting it right or left. It says we're shifting by pi over 2. Pi over 2 means, let me change colors. what used to be at 0 will now shift to pi over 2. So I'll start my curve at pi over 2 instead of 0, which is why I have the yellow highlight there, to let you know that the curve, the mother function, just got moved. And so here's what it looks like. Now, when you're doing this by hand, it probably is a headache. Remember, we're not doing this by hand on homework or the test. We're using the MyMathLab widget. So in the widget, you would push the button for sign. You would plot that sign starts at 0, 0. The widget will pop up, and you would go to where it says phase shift, and you would enter pi divide 2. And that would take care of going right pi over 2. It will graph it for you. Okay? So while you're finishing that, I'm actually going to pull my MathLab up and we can practice a few. The next 2 slides on your notes are practice examples, and I will start class tomorrow with those.
Yeah.
Yeah, we'll do those 2 at the beginning of class tomorrow. So if you look at the homework, you might want to, I don't know if you want to keep the notes out to help you with this, but so like this one right here, it says determine the amplitude, the period, and the phase shift, if any, of the graph. It says part 1 of 4. So they're walking you through it. By the way, I can't, oh, I can zoom in. There we go.
Whoa.
Whoa, too much. Hold on.
Yep, it works.
All right. Amplitude is the one in front. So the amplitude here would be, oh, it changed. I was going to say 3 over 4, but it changed. So it would be 4/5. The period is unchanged, so you would type 2 pi. There's also no phase shift, so you would type 0. And then to graph it, you would go in and plot. This one changed again. Good grief. So the amplitude's 4 over 7. Thank you. Period is 2 pi like normal. There's no phase shift, so you'll type 0. And then now to graph it. So the mother function's cosine. Remember which one's which. Cosine starts up. Kind of looks weird here, but it starts up. Best part of a roller coaster. And then it's going to say, does it? Oh, there you go. So it says cosine. You're going to plot the mother function 0, 1. There's the mother function. Now I'm going to change it. What was my number? 4 over 7. 4/7. When you get to the multiple choice ones, they are a little overwhelming because all the graphs kind of look the same. Remember, you're asking yourself,
hey, good morning.
okay, so this one's reflecting over the x-axis. So we're going to imagine the cosine function. Cosine starts up at 1. It would reflect over the x-axis, and then it would also be this 3 right here is the period. Normally is 2 pi. Now it's 2 pi over 3. So the curve is having to finish faster. There's only 2 pictures up here where the curve is finishing faster. Kind of hard to tell because it is a little overwhelming, but that would be either A or C. If you notice, look at the grid in the background compared to B and D. The curve here, from here to here, the low to the high, is in basically 2 units. Over here, the low to the high is stretched out. So you see the difference?
So you can use process of elimination to help you decide which ones can't be possible. Then you have to actually figure it out. So looking at the difference between these two, notice this says 2 pi over 3. Notice this one doesn't. And we said that to get the new period, it'd be 2 pi divided by whatever's right here. So it'd be C. Okay? You also could type it in your calculator and type the graph, which brings me down here to these last two. Oh, let me take that one off. I'll take 17 off. 16's not bad. To type it in the graph in your calculator, you do have to change your calculator to polar mode, and then you would just see which one it matches. If y'all will try that, if you have trouble with it, let me know tomorrow and we can address it.